Okay, so we have a simple user data model that we have mapped to a relational database, and we would like to be able to interact with it. So first, let's insert a couple of users in here. So let's grab this and go back to the database and insert a couple of these. So let me just blow that away. I don't care for that. Let's insert into the user database, into the user table, a couple of users. Alice, what are you complaining about? What's wrong with this? Semicolon. What don't you like? Insert into user. Oh, thank you. And are they all here? First name, last name, pass username. Oh, okay, so they're in the wrong order. Let's see. I forget what the order in which they were created. All right. So ID, first name, last name, password, username. So they're backwards, right? So let's put them in the right order. Oh wait, no. Username and password? Oh yeah, no, backwards. Okay. Username, move the passwords here. Is that how I declare them in the... All right, let's see. So let's select these four, and let's insert. And I didn't like it. Insert into user, Erica, column count doesn't match. Is it auto-incremented? Oh, I guess I'll create just a couple of these. I'll add the IDs. All right, I inserted those, and let's take a look at what users we have so far, and we should have those 4 users: Alice, Bob, Chuck, and Dan. All right, so they're there. Let's go and fetch them using a Restful API. All right, so a Restful API, as we mentioned earlier, right, allows us to map a URL to some logic that might expose some data model, some data. Maps these URL as if they were data resources, right? The URL has been used quite often, typically for accessing static content, right? Typically, more popularly is used for accessing an HTML page, a CSS file, JavaScript, something that's static, okay? But as the name suggests, URL, it's a universal resource locator, right? That allows us to find anything in the universe here on Earth, and it has a domain that presumably uniquely identifies all servers around the globe, and then it has a path that allows us to navigate through some resources and identify a specific resource that we want anywhere in the network here on Earth. When we get to Mars and other places, we'll need to expand what the naming convention might look like. But while we're here, the URLs can uniquely identify anything here. And so it doesn't have to just map to something static. It can map to something like data in this case, right? So let's map this URL to return all the users. In this case, use the find all in our CRUD operator. So let's do that. Let's in our directories here, let's create another class, and we'll call this the user service. So typically, just like there will be a user, there will be one repository per entity. typically there will also be one service per entity. Right? So in this case, we only have one entity, the user entity, and the user service will expose all data, all operations to manipulate users. Same thing, the naming convention here, it will be that it will use the root package name, right? So that the Spring framework will know that it needs to expose this URL and make it available as an HTTP endpoint. Otherwise, if you put it outside of this package, the service won't work, right? And you'll be asking me on Piazza, I've declared it, I did exactly what you did in class, but I can't see the URL. Why is it not being mapped? And the default answer will be, did you put it under the package that you declared at the top? All right, so under here, we'll put it under services. And here's our service. You can barely see that. So to expose this as an endpoint, we're going to annotate this as a REST controller. Right? And we're going to, maybe it's not REST controller? No, go away. It is REST controller. What? Why didn't it find it before? All right, there it is. So REST controller. And what this does is that it puts it already available as an HTTP resource. Right? We just need to map it and say, well, what do you want to map it to? You need to tell me the URL that you want to map it to. And to do that, basically we want to say, well, this is the data that I want to provide. In this particular case, we want to provide maybe a list of users. So this might be find all users. And we might respond with whatever query we might do in the database, right? So we'll need to import the Java util list and also the user that we just declared earlier. And right now it's not responding anything. All right, so to respond to this, we can see if this is even working. We can create perhaps a local array list of users, a new array list of user. Okay, maybe we can import that Java util. There it is. Actually, this could be just list. And then we can return users. Now this would be an empty array, right? Because we haven't put any users in there. And we're going to map this based on the naming convention that we said earlier of using RESTful naming conventions. We're going to say that this is going to be a get because we're going to be reading, right? We're going to be doing in the CRUD. We're doing the R, and this will be a mapping. We're going to be mapping it to /user. Okay, /user, right? Because the entity is user. And let's import the get mapping. All right, so let's try this. I'm going to restart the server. Let's restart. And let's see what comes out from the other side. What did I do? Preferences? All right, whatever. All right, so we can go here and at the from a URL, we can generate that GET request. We can say localhost, I believe it's running at 8080. And we say user. And indeed comes back with an empty array. Right? If we populate that with, say, a couple of users, we can say user Alice, new user. And then we can populate, maybe set the first name as Alice. And maybe Alice, set last name as Wonderland. Okay, and if we restart the server, oh, we just created it. We never added it to the list. Sorry. Stop. let's add it to the list. So this might be users.add.alice. There we go. Let's try it again. If we go to our endpoint and refresh, notice that indeed we get the instance we just added to the list. Right? Whatever we add there, that's what we get a hold of in. But now this is an object that is transient, right? It's not stored in a database. Has no mapping to anything, and we need to be able to distinguish, which objects are transient, the ones that we instantiated here locally in our local variables, and distinguish them from objects that are managed, right? That are mapped to some record in a database. Okay, so we have Alice there. We could instead get a hold of users using the repository we created earlier, the CRUD repository. So let's inject that in here. We're going to say auto-wired, and we're going to be using a design pattern that has become very popular in modern web development in general, is the inversion of control, where we no longer handle the life cycle of some singleton objects that can be used widely across the entire framework. Instead, we delegate that to the framework and say, hey, framework, you handle the life cycle of this object. Create an instance across the entire framework. Whenever I need it, I'll ask for it, and you will instantiate it and make it available for me right here at the source code. So auto-wire, that's what it does. It allows to delegate the life cycle of these instances to the framework. So I want a user repository. So what this will say is that, hey, you instantiate it, you handle it, and then inject it and make it available to me at this variable whenever I ask for it. I don't want to instantiate it, right? And that's perfectly, right? Because this repository might be used here. It could be used in different places. Okay? And so this is a perfect example of a singleton design pattern, right? Where I have only one of these instances hanging around, and I have it injected at any time that I need. It'll be cached by the framework. I don't have to handle any of these life cycles, and be bothered by managing its life cycle or instantiating it and then destroying it and instantiating it again and destroying it. It's injected for me dynamically. All right. So this user repository is as we saw earlier. It extends CRUD repository, meaning that it has some really cool features, such as implementing functions that have some very generic implementations. So, for instance, notice that it has count, meaning how many users are there. Right? It has delete. It has delete all. Delete by ID. If you know the ID of whatever you want to remove, it'll be removed. Notice that none of these have methods that are specific to our entity. Nowhere do you see delete user, right, or count users, or find all users. Instead, they are very generic. Okay, and they are by design, right? Because in this particular case, it has been configured, right? It has been configured to work with user, but it could have been configured with anything else, right? It would have been configured with any other data type. So here, what we can do is that instead of returning the users that we added as in this array list, instead we can return the find all, whatever find all returns. Now this is complaining, says that it actually returns an iterable user, right? Which is fine. We can cast it. We can cast it to list user, I believe. All right, so let's see. Let's what this will do is do a final, maybe a select all, select star. Let's rerun this. And when we hit this, notice that we have the 4 instances that we had inserted earlier. Right, here's Alice, Charlie Brown, Bob Dylan, Chuck Norris, Dan Brown. Oh, Dan Brown. Okay. Yeah. So the four users we had inserted earlier. Right. So these are read directly from the database. Right. And we can look at also down here, very small. We can look at the query, the Hibernate query that was used to generate this. See that? You know, select user 0 ID, first name, last name, username, everything from the user object, from the user table. So this is the literal string that is being used underneath to talk to the database. All right. Seldom you would have to care. But sometimes, you know, if there's a join that doesn't work very well, you like to look at it and maybe optimize it, and so you can take a look at what is it that the default behavior is doing. All right. All right. Where did it go? There we go. All right. So we were able to retrieve that. How about retrieving an individual user? All right, so let's retrieve an individual user. We can extend that, this get user, and do another mapping here. It says get mapping that has a user followed by user ID that might return an individual user. Right? If you give me the ID of the user, I can retrieve that particular user. Again, following the RESTful naming convention we mentioned earlier. So this might be called find user by ID, right? And presumably you would pass me the integer of the user ID, right? But that ID comes from where? From the path that we need to parse. To do that, we have annotations to do that. We can use the annotation path variable. And say, well, we're going to parse the user ID out of the path variable, and we're going to instantiate it and pass it to you as an argument. Okay? All right? Now, the reason you need to provide an ID here and the name of the path variable is because you might have multiple IDs, right? You might have multiple path variables over here, right, with different names. So you need to know which one are you parsing. Okay, right now we just have one, the user ID. Okay, so you need to tell me which one. All right, excellent. So this is complaining, saying that we're not returning anything. So let's use our user repository. Our user repository, notice that it has a find by ID, right? And it knows that it's expecting an integer, right, to be passed in there. So let's use that find by ID. Notice that it doesn't say find user by ID. Again, because it's a generic API, we pass in the ID, right? And then we can return the user repository. All right, so this is complaining, saying, what is complaining? It says that optional user. So it might be that that ID, it doesn't exist, and the user actually might be null, right? It might actually be in the database. So to deal with the fact of the response might be null or not found, I haven't found this record in the database, the abstraction around handling this missing record is the optional, right? To handle non-existing data. So that's fine. We can change the return type to be optional user, right? If there is a user, if there is an object, it will be unwrapped out of the optional class, and it will pass in the actual instance that was found in the database. So let's try that out. Let's restart the server. Oh, can't get over this font. All right, so let's move this over here. So this is still working. And I can retrieve now with the path parameter, if I follow just one, Notice that it retrieves that just one user, or 2 for Bob Dylan, or 3 for Chuck Norris, or Dan Brown. Okay, all right. So there it is. We have the find user by ID. There's a couple more. Let's take a look at a couple more of these. All right. So it might be that some of the finder methods, or some of the delete methods, or some of the operations that are there that are provided by the generic repository just don't cut it. No, there's a particular predicate that you want to implement that is just not part of the default implementation. So to handle that, you can extend your own. You can provide your own query selectors, right? And then wrap it around an API. So, for instance, you might want to find a user by username, or by credentials, username and password, right? So to do that, we can go to the repository and declare the interfaces that we want to extend. For instance, we might want to retrieve a user, public user find user by username. Right, and we can provide as an argument maybe the username that we want to filter by. Okay, and we're not going to actually implement it. It's an interface, right? So we don't actually implement it. Instead, we tell it, what actual query do we want to make out to the database, right? And then the finder method will just wrap whatever magic happens behind that actually does the query. So to do the query, we declare the query, we map it to the following SQL that implements this, right? So query is also part of the JPA repository API. There it is, the JPA repository API. And you provide here a pseudo SQL-like query, right? It's not exactly SQL. Instead, is a object-oriented version of SQL, okay, called JPQL, right, or Java Persistent Query Language, right? So it starts off very similar to what you would expect in SQL. Select, right? But here now we're selecting a user instance, right? So this is a user variable that needs to be of type user, right? Of the class user, not the table user. We already know that the user class is mapped to a user table, right? But we don't care about the low-level table. We want to keep it way up here at the object level, right? The fact that it's being implemented as a user table is it's an implementation detail, right? Tomorrow we could decide that it's implemented in an XML file called user, right? Or a JSON object called user, right? We can define different mappings, right? So we want to keep it up here. So user is a user instance from user class user variable, right? So this user here is a user object of type user class, right? And here we can have where the user dot username, where username is a field, well, not a table field, is a class variable, right? Call username under the user object of type user. So and then make it equal to some placeholder, right? Where in this case it would be this username over here. Okay, right. So somehow we want to put whatever you pass here as an argument, we want to put it right here. Okay, but we don't want to do concatenation. We don't want to be vulnerable to SQL injection. We want to make sure that whatever we pass in here has been vetted, has been sanitized, right? Doesn't have any weird characters. So instead, we put a placeholder here. Okay, we put a placeholder here. Notice that it has a colon in front of it, meaning that this is a placeholder. Right? Just like it would be like a query question mark if this were a prepared statement. You can give the prepared statement names, right? So we want to map this username to that username. And I'm just going to call this something user name, right? Just to point out the fact that the name of the variable doesn't have to match this placeholder, right? And I'm going to go far and going to say that this is you. All right, so they don't match at all. This doesn't have to match that, and this doesn't have to match that. Okay, the mapping occurs right here. We're going to say param, is it? Param, yes. Param, and then we say here, what does it map to? That's where the mapping occurs. Right? This is saying that this u maps to this u, and it's that variable. That's the value, and that's the field, right? The property name. That happens to map to a field in a table also called username. All right, but that's incidental. Everybody okay? All right, now that we have that done, we can go back to our service and implement here find by username, right? And so we can say get mapping a user. And I'm going to break one of my rules. Username. Well, what if I do this? What's wrong with that? Notice that from the server's point of view, there's no way to distinguish between these two URL patterns, right? They both start with /user, and they both end with something, right? A placeholder. Okay, they both map to the same URL, right? If you type /user /xyz, it would not know if you meant that user that xyz is a user ID or if that's a username. Yes? Okay. So to distinguish between the two, I'm going to do this. Okay, now this maps to /user /username /whatever. Okay, so now they're distinguished between the two. Okay, so careful. It's when you compile in the Maven, it'll tell you if you have two. It'll say ambiguous mapping or something, meaning there's no way for the server to distinguish between the URLs. Right, in the Maven build, it'll tell you. Right, so if say public. Here you have a user, find user by username. And this will be a path variable, call username, and it's going to be mapped to a string username. I'm deliberately not calling it the same. Right, notice that this user ID, I didn't call it ID here because they don't have to match. All right, so I just want to point that out. And here you would say return user repository, and then the find user by username. There it is. And I'm going to pass as argument the u string. Everybody okay? All right, so let's try that out. Let's restart. And here now I can say /username Alice, and I guess I don't have an Alice. I don't have an Alice? Oh, username is A Wonder. Okay, so it would be /username A Wonder returns just Alice, right? So so I can retrieve Alice either by username or by 1. But what's wrong with this implementation? What's wrong with this implementation? Notice that that this is not following the REST API, right? Because the REST API typically would be entity followed by ID, followed by entity, followed by ID, followed by entity, and so on and so forth. All right? This instead is what? This is a filter, meaning I want you to return out of all the users, the list of users. I want you to return the one whose username is equal to username, right? Equal to whatever it passed. Okay? And we said that if it had to be any predicate, instead we should use the queries. Question mark, username, whatever. Yes? Okay? So basically we would have to do something like this. User, ideally we would look to be able to do something like this. Username equal and then username. All right? Unfortunately, JAX-RS does not support this kind of URL. All right? This would be the pattern perfectly. /user, username, I want to pass the username as an argument. Right? Unfortunately, this is not supported. What the server does is that when you pass the URL, all of this is ignored, right? For doing the mapping, right? All this query over here is ignored. Everything after the question mark is ignored, right? As far as URL pattern mapping is concerned, right? It just ignores everything after the query. So you providing that is really as if you would have done that, right? And what's the problem there? Notice that this is the same as that, right? Again, you would have a collision of URL patterns. You see that? So basically, if we want to support the RESTful API, we're going to have to somehow move this feature into over here, into down here, all right? And what we're going to have to do is either return all users if there's no query, but if there is a query, then apply the query. Make sense? Right? So somehow we're going to have to parse the parameter, the query parameters here from the URL, and to do that, basically I want to have the username if it's available. Maybe it's not there. Maybe it's not there, right? But if it is, I'd like you to parse it out and give it to me, right, as an argument. So to do that, we can parse from the request. I think it's param. Yeah, request parameter. And the name is username, if you provide it. Right? It might be not there, but if it's there, pass it around. And we're going to have here a logic, right? If there is a username parameter, then we're going to use that. Otherwise, we're just going to do whatever we were doing earlier, right? So we're going to say, if a username is null, then we're just going to do whatever we were doing. So I'm just going to remove that because we're not doing that, right? We're not using this. We're going to take that and we're going to do what we were doing earlier. We're just going to return all of them, right? Otherwise, if we do have a username, it's not null, and I actually have a value for it, I'm going to return this. I guess this could be the default. Right, so if I have a username, if I don't have a username, I return find all. Otherwise, I return find user by username. Oh, this returns an array, and this returns not an array. Okay. I guess we'll have to add the user inside of an array. Let's do that. So this will be user, and we'll create an array real quick. So this will be list user users, and this will be a new array list user, and we'll add to users the new user that we have found, and then we can return users. All right, and what else here? We have this is expecting as an argument the username, so let's do that. All right, excellent. Let's see, any other configurations that we need here? Okay. Do we need to load request param? We did. Anything I'm missing? Let's see. Find all users require. Oh yeah, one other thing. You might not pass in the username, right? It might be you might, if you don't pass it, it's okay. So we're going to configure it. So that it's not required. So we're going to configure as saying required false. So if you don't provide in annotations, if you don't provide an argument, it'll configure the default property. But if you provide an additional, if you provide multiple parameters like here, then you need to specifically say that this is a name. The name of the parameter is username. Okay. All right, let's try it out. We'll need to remove this. We can't do that anymore. And let's restart. Okay, so if we just do user, we get all the users, right? But if instead I want to filter, I can say I only want the one who has the username a wonder, right? It just returns just Alice. Make sense? Right, so it behaves one way or another. So this what might be different predicates. The one that has a particular salary or particular date of birth, particular starting date, or whatever, right? Or maybe several predicates that would be added to the query string. Make sense? All right. Awesome. Here's just another example of a credentials. All right, so let's take a look at updating data in a RESTful service next.